Do you struggle with a complicated untested code base? Well, in this video, I'm going to show you how to rapidly write tests around your existing hard-to-test code. Look at this method. It's very long. It has deep, nested conditionals. It would be very hard to test this code. And your first inclination is going to be to spend a lot of time trying to figure out what it does. And that's going to be a mistake. Let me show you another method you may have heard of called Characterization Testing, but it still has some downsides. It's made up of 4 different steps. The first step is just to use the code in a test. And the next, we're going to write an assertion for that code that we know is going to fail by giving it some garbage value. The next thing we'll do is run the test and let the failure tell us what the code really does. And finally, we'll change the test to expect the correct behavior. So let's get started here. We'll create an instance of the Gilded Rose service class, and in its constructor, it needs an array of the item class. We'll create an item and just sort of fill in whatever values we can think of to finish out this constructor. Now that we have all this data filled in, we can call the update quality method. But now, what do we assert? So we're going to go back and look at this update quality method and see what we can figure out about what it's doing. Well, we see it's named quality. There's several references to quality throughout this code. So it looks like we're probably going to want to do an assertion on the quality of the item. And here we'll give it that obviously bad value, negative 100,000 in this case. We'll look at the output of what the test ran and then replace it with the correct value. So given that input that I came up with, the correct result is going to be 0. Well, now what do we test next? So we look through, we can maybe come up with how many items are in this array? We gave it 1, but do we still have 1 after it runs? So we'll give it an obviously wrong value. We'll run it again, and we'll see, yes, it still has 1. So let's update that. Well, we could also look at maybe the sell-in. That was the second parameter there. So let's run that, give it another bad value. And in this case, it comes up with negative 1. So we'll replace that. But look at all these other data inputs we gave this. If we were going to go through and do this process over and over again of writing an assertion we know fails, giving it a bogus value, running the code, updating the assertion, that's going to be really tedious and slow, and we're going to be here all day long. Let me show you a better, faster, easier way to write these tests. So we're going to start the same. We'll use the code in a test, but this process called approval testing or snapshot testing is going to have a different approach from there. So the next thing we're going to do is just verify the result. So we'll call approvals.verify, and we'll pass in the entire array of items that's part of the Gilded Rose service. So now when we run our tests, we can see that the approvals has launched a code comparison tool. In this case, I'm using IntelliJ, and it's looking at a file here. So the file's named after the class name of my test, the method name of my test, and then it has received.txt at the end. And then also inside of the content of that file, we have the default toString of our item array. This isn't going to be very useful. We have no idea what this means. So let's come up with a better output. So the next step in the approvals process is going to be format the output. First thing we'll do is use arrays.toString to get a better looking toString for an array. That's going to remove that capital L. It's going to give us a closing square bracket, but we still have a problem with item toString. So let's go add a toString method to that class. Inside of item, we can just use IntelliJ to generate a toString for us. And here we're going to capture every field within that class because we want to cast a wide net and grab everything that could possibly be important for this test. At this point, we don't know what's important. As we go through and look at this, we can see that we have a toString on character and realm that aren't very useful because they're just pointing out the default toString for those two classes rather than giving us what the data values are. So we'll repeat the process in each of those. We'll open up character. We'll look at that class, and we'll use IntelliJ to generate a toString within that class, and we'll follow the same pattern with realm. We run the test again, and we can see now as we scroll through and look at this output, we can see all the data that returns from running this update quality method. So the final step in the approval process is going to be approve that output. And to do that, it's pretty simple. All we need to do is open up that received file again. We're going to rename it. We're going to change received to approved. We can overwrite the file. Now we'll go back and we'll rerun our test, and it's green. Now let's look at the code coverage that this test generated. So we can see with this single test we've got 42% line coverage, but only 11% branch coverage. And branch coverage is going to be much more important than line coverage because that means we're covering the actual logic of the code. So we want to get that up to 100%. So let's look at a different way that we can do that. We'll come back to the code and we'll do a little refactoring that will help us get to the point where we can cover all these different conditions. We'll extract a variable for the string result, and then we'll take all this code and we'll extract it into a new method. Let's call it doUpdateQuality. Our next step is going to be to look at the method that we're trying to test, and we want to find out what data is used in each of the conditionals, each decision that the code is making. And we'll use that as parameters into our test. So we can see name is something that's used, quality, and selling are all different values that are used in these conditionals. So we'll go back and we'll extract those as parameters. Next, we'll take each of those parameters and we'll make it into a variable. Now, instead of using approvals, we're going to use combination approvals because we want to hit all these combinations. We're going to verify all the combinations. And instead of giving it the value, we give it a method reference so that it can call the method for us. Now we need to convert these single variables into arrays. So we'll have a string array and two int arrays. But instead of using primitives, we actually have to convert these into integer types. And now we'll make all these arrays. And we'll pass each array into the verify all combinations method. When we run our test now, we can see that we have some new input, and it's actually showing us what parameters we passed in to get this output. So this is a lot more useful for us. We'll close this, and now we can start to generate some more combinations. We'll look at the code, and let's look at what data values are used in those conditionals. So we see a bunch of different names. All we're going to do is copy and paste them into our name array. Once we've captured all of those names, we can rerun our test. You can see we've very quickly got 4 test cases now. If we run again with coverage, we can see what impact we've had on the coverage. And just by adding those 3 extra names, we now have 50% branch coverage. But let's keep going because we want to get 100% coverage. So we'll go back and look at the code. What else is it using in decisions? Well, we see we need quality. So we probably want a quality of 50 for that conditional on line 20, maybe 49 to hit both points. We need a sell-in of 11 for the conditional on line 24. If we keep scrolling, we'll see we have another case here where we need a negative sell-in, so we'll give that one -1. So we'll come back to our code and input these arrays. We need a sell-in of -1 and 11 for those conditionals we saw on that, and then 49 and 50 as well on quality. Let's rerun the test with coverage and see what kind of coverage we get on all of those branches. So now we have 36 different test cases running just by adding a couple of values into our arrays. And just like that, we have 100% branch coverage. So you can see how easy it is to produce really high coverage tests using this approach. Now let's look at the file that we generated. This received file has a bunch of data in it, but a lot of this data looks repeated. Let's highlight this owner property as well as realm, and let's see if we do a find in this file if it's repeated anywhere. If we look through, we can see it's actually repeated in every single instance, so we don't really need that in our file. Let's go filter that data out. And this is part of the aspect of approvals and snapshots. You cast a wide net to grab everything you need, and then you filter out things that you maybe decide you don't need at the end. This file is much easier to look at this point. If we're happy with that file, we can go ahead and approve it like we did originally. So what we'll do is we'll just rename this file change the ending .received.txt to .approved.txt, overwrite the file. We can now rerun our test and make sure that we are green. And just like that, we've covered 100% of the branches of this code. You've seen how powerful approval testing can be to write tests around your existing code. If you want to learn more ways to test your code, subscribe to my channel. Thanks for watching, and I'll see you next time.